Let's see. Ha! Welcome. Glad that you joined us. Let's do some SAT systems of equations. So, systems of equations are some of the most common math problems, especially on the SAT. They come up somewhere between 2 and 4 questions per test, so they're fairly frequent themselves, but as you'll see going through, they also just require a bunch of the requisite skills from pre-algebra and algebra. So today's video will probably just be a useful refresher of some of that vocabulary and some of those skills, as well as in a dalliance into systems of equations. Before we do dive in though, let's review some of those pieces of vocabulary or some of the skills, get a framework for what we might expect today. First is we're going to be dealing with linear equations. Mostly we're going to deal with them in slope-intercept form. So if you're not yet familiar with slope-intercept form, check out a video or check out our library of videos. What else we might need to know? So basically systems are telling us we're dealing with 2 or more of those equations on the same graph. The last point that you might need to know is that when we're solving these systems of linear equations, we are finding the point where they intersect each other. So what point, if we have these 2 lines, what point would be on both of those lines? And then we're also going to talk about the 2 mostly used and the 2 most common methods, substitution and elimination. Got it? Okay. This first question, let's read it out. We'll assess what we notice, and we'll get a game plan. The equation's negative x plus y equals negative 3.5, and then x plus 3y equals 9.5. If you can solve this, if you remember from pre-algebra or early algebra how to solve this, maybe pause the video now and do so. All right, but if you're not as familiar, let's see, or if you want to check how you did, let's just see how we might tackle this. What I notice is we've got the word system of equations clearly labeled for us. They usually will let you know. And so whenever you see those words, that's your trigger to say, okay, I'm going to start using some of these skills that I'm developing now. Next thing I notice is they are, of course, both linear. And we know that because there's no exponent anywhere. It's just x and y related to each other arithmetically. And we're going to basically say, if we could graph those 2 lines, what would we find as the place where they intersect? I also notice there are no answer choices. It's not multiple choice. The test will have, at the end of each math section, a series of questions that they call free response or grid-in questions, where you don't have the luxury of multiple choice. So we're going to have to tackle this one. Rogue. What we can do here is one of 2 things. If we have these systems of equations questions, there are basically 2 primary methods, and we'll go one by one. The first one, substitution. To substitute, the first thing that I need to do is to choose one of the variables, either x or y, in that equation that I think is easy to isolate. So I'm going to choose this equation, and I'm specifically going to choose the y variable because I notice there's only one operation I'd need to perform. I'd have to say add x to both sides. So I'll rewrite the equation, negative x plus y equals negative 3.5. And if I'm trying to isolate the y value, the y variable, then I'm just going to add x here to cancel it, and add x to the other side to keep the equation balanced. And so I'll end up with y equals negative 3.5 plus x. That's the first step. Isolate one of the variables. The second step, though, is going to be exactly the name of this method. So it's called substitution. We're going to substitute. All right, so since we've isolated y, basically we can go into the other equation where we see y, and we can plug in negative 3.5 plus x. We'll end up with x plus 3 times the quantity of negative 3.5 plus x equals 9.5. So if we've got all of this, we can isolate x fairly easily. We're going to first distribute 3. We'll have x minus, because 3 times negative 3.5 will be minus, and we'll do this quick in our heads, 10.5. Can we check that? 10.5 plus, and then we distribute the 3 to the other x, 3x, and we'll say x, oh brother, minus 10.5 plus 3x equals 9.5. And then we're going to combine like terms. That's 4x. We're going to add 10.5 to both sides, and then x will be completely on its own. And all we'd have to do, you might be ahead of me on this one, is divide by 4. And x equals 5. Bada bumski. Okay, so x equals 5, but we want to check back to our question. Is that what it's even asking us for? And it's not. So be careful. This is a mistake that, I make it often enough, and I'm an adult. But adults make mistakes anyway, so you might make this mistake. And if you do, just remember for next time to check the question again. So we want to find y, which means what I have to do with this x equals 5 is choose one of the equations to plug that back into, so that now instead of having only x's, you only have a y value. Let's see. So first one, negative and x equals 5, I'll just plug that in, plus y equals negative 3.5. And you know isolating a variable. If you don't know isolating a variable, check out this video. Is that good? Yeah. And we're going to add, there's a lot to isolating a variable. You wouldn't necessarily think of it. There's vocabulary. You need to know constants, coefficients, variables, and you need to know a very flexible order in which it's supposed to happen, because you got a lot of questions to ask. Is there a multiplier? Is it a fraction? How many different terms are there? Let's isolate y. So we got y equals negative 3.5 plus 5 is going to end up with 1.5. 1.5. There we go. That's ultimately what we're looking for. That's our answer. Substitution. Review. First step, substitution. Isolate one of the variables. It doesn't matter which one. Just choose one that's easy to isolate. Step 2. Substitute what that variable equals into the other equation. And all of a sudden, you can just isolate whatever's left over. So you'll notice what we did to do that was just get x involved with y out of the picture. The reason that works is because now we don't have two unknowns. We just have the one, x. All right, good. We'll notice that in the next method. That's going to be pretty useful. Let's move on. All right, next method. If we go back and we say, all right, we didn't want to substitute here. And that's totally your prerogative, because sometimes substitution actually is not the most appropriate choice. Let's go with our second method called elimination. Now, teaching this to classes or to private students, usually elimination is more exciting. If you want to choose one method to use the whole time, go on ahead. One's going to be easier in different methods or in different questions, but it's up to you. So let's see how elimination works here. So whereas substitution was about isolating a variable and then substituting what it equals into the other equation, elimination is a little sneakier. It feels a little more like magic, which I think is why it's more exciting. So what I need to do to notice that I can use elimination is I need to look at these equations and see if there are any variables that have the same or opposite coefficients. Real quick, coefficient is the multiplier for a variable. So I look at this, I see x has a -1 coefficient in the first equation, y has a +1, and then I see x has a 1 and a 3, y has a 3 in the second equation. And I do notice that that means -x and x are really perfect for elimination because they have the opposite variable coefficient. Bada bum, ski. The reason it works is because if we rewrite these one on top of the other, almost as though it's addition, we can go down the line and basically add the entire second equation to the first equation and combine like terms, the x's, the y's, the constants. And when we do that, we'll find -x plus x is going to equal 0, which, just like with substitution, we wanted to get one variable alone. Now all of a sudden we're only going to have y's here. We're only going to have one variable on its own. And then we say combine the y's, y plus 3y is 4y. Make sure you do to the left what you do to the right side. So we have to say -3.5 plus 9.5 is going to equal 6. Divide by 4. We done? Almost. We could simplify that to 3/2. Or we can make that a decimal. Now, the test does not mind, as these grid-ins go, you can grid in 1.5, and that would be exactly identical to 3/2. So they're the same thing. The grid-in will have a video you can watch here about how to answer and fill in grid-in questions. They're pretty forgiving. Like I said, 1.5 is fine, and so is 3/2. Anyway, we check back to our question because we're not making that mistake again. What are we looking for? Y. Did we find it? Absolutely. And look how much less time it took to eliminate. People love elimination. They do. It's fun. Okay, cool. So those two methods, if you got substitution, you got elimination, and you realize all it is just getting one variable and getting rid of the other one, then you can solve all of these questions. Good. I'm so proud of you. So, call to action. All right, if you liked this video, or if you didn't, check us out. What do we say? What are all the things to say?
I don't know how many videos you're allowed to put in that top bar throughout a video, so.
Go to my page, make sure you hit subscribe,